I need to put some lights on here. Oh, hello. Alright, hello, welcome to the stream. Let me turn some of this stuff down. Is the music? Okay, set some lights on, and then we'll talk about what's on the agenda for today. All right, 1 light, 2 lights, 3 battery lights. We have our why is it not focused? Focus. Oh, it's broken. Hold on. Hold on. One camera. Two cameras. Three cameras. I have found out, oh god, a number of interesting things about USB webcams in the last few days. At least these Logitech ones, they do not really like sharing bandwidth on a USB hub for some reason. Nothing, they don't work. Alright, so hold on. This one's unhappy. Let's make it happy. Yep. No, that's the wrong one. Wrong one still. Why is it not plugged in? Why you no work? Isn't it this one? Hold on. Can't tell which one it is that I am messing with. It's this one. Alright, off. And on again. Properties. Hello. No. 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 Ugh. What is your problem, webcam? Sorry about that. Something's not working. Alright, so this one's still good. This one good? I don't think so. I should have worked on those issues before I started the stream, shouldn't I? Oh, okay, there it is. Okay. Boop. Just watching me mess up all this stuff. Well, I guess it doesn't really matter because this thing over here is still busted from yesterday, and I've been messing with it some more again, and it's still giving me grief. And so I really I'm not feeling very productive, just soldering, desoldering LEDs. And so what I'm going to do actually is revert back to working on version 1 die while I wait for the next board to come, which should come either tomorrow or the next day. And I'll just put together, the next version of the board, which I should have less issues with. And in the meantime, I can work on the accelerometer readings from the version 1 boards, because that's exactly the same as on this one, and figure out how to properly detect, dice state, right? So let me grab something here. Here's some dice over here. You can see them. Oh, the black one comes through. The other one's over bright. Here. It's still bright. But yeah, so we're gonna work on these, or we're gonna program these, and use the boring LEDs. But that's okay, because we won't worry about LEDs. We're actually going to be doing some firmware programming, some C# programming. Actually, I want to be here. And something else. What I was going to say. Oh yeah, we're going to do interesting stuff in Unity. So it'll be a change of pace, but I think it'll be interesting. So the first thing, though, that I have to do is update my firmware code. I've been trying to make my... I just need to stop this music. Whoops. All right. Right, so I need to work on the firmware code. I've been trying to make it so that I can sort of switch back and forth between version 1 and version 2 for a while until I have, final or whatever, like actual DICE version of the version 2 boards with the RGB LEDs. And so I've been refactoring a lot of code to sort of like abstract out the LEDs. And in fact, that's what I was sort of trying to get at yesterday, or to debug my refactor. I did a little bit more this morning, and I like actually the way it's looking significantly more, but now I have to implement a few functions to make sure everything works correctly. So on my website, if you're interested, there is sort of a small introduction to like the firmware architecture. And so I won't go into like too much detail, although it's really not that complicated. There are a few like core components that like talk directly to the devices, and then several layers on top of that to actually do the fancy stuff like animations and decoding Bluetooth messages and etc. etc. In this case here, oh yeah, I'm missing all the lights, all the webcams. That's so weird that this is just not happy. Why are you not happy? Nope, nothing. I'm not hearing the computer say hello, which is weird. Let's try this instead. I'm just plugging USB stuff back and forth. This webcam's not talking. How about here? Okay, let's try this again. Oh hey, now it's working. Cool. All right. And do we have scope cam anywhere? No. Dum 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 dum. Nope. All right. Well, forget it. I'll just turn this off. And you know what? I'll use that space for writing some what we're gonna do today. You need more screens. Oh, you started watching Skyline? Yeah, she's amazing. Her stuff's just so great. It's completely it's like huge, very, very much more professional looking. All right, so here I want to add a bit of text. Create. All right, we're gonna call this agenda. Whee! And the agenda for today is finish writing. Whoops. LED abstraction. Then we are going to do get back to telemetry on Unity. Then we're going to try to record video from Unity. And I'll explain why. Then we will try to create wave files from Unity with custom data, and then well, actually with telemetry data. These are all the things we want to do today. Well, maybe not today, but that I want to do. And so the reason I'm trying to do this, let's pick a font that will make it fit. Let's see. Oh, actually, sort of good. Alignment, right? Perfect. Cool. All right. Oh, I should write agenda. There you go. Okay. So, right, the reason I want to do all these things, right? So I want to get back to a working, like a I want to get back to a dice that is working, that I can reprogram at will with the old LEDs. But like that sends all the Bluetooth data over to the app running on the PC, and also can run on the phone. Get the send the telemetry data, which is what I call the accelerometer readings, over to the app, which actually have most of that already written. And then what I want to try and do is make an app using my favorite environment. So it's going to be a Unity. So it's not going to be a game, but it'll use the Unity engine just because I'm familiar with it. And it has a lot of functionality, like tools that I can just, use out of the box. I'm going to try to make an app that films, like my play area, and receives all the telemetry data from one or more dice, and records that telemetry data in WAV files that are timed with the video, right? Like maybe if I even get super lucky, I can put the data in extra channels in the video file or something like that, like extra audio channels. I don't know about that. Even if they're separate, it's fine. But the reason I want to do this, take video and record telemetry data, is so that then I can open all these files in a video editing software and actually see, right, the behavior of the die on camera along with the readings from the accelerometer. The entire purpose of this is to be able to sort of like suss out what the readings look like in different conditions, right? Like, so when I have a couple dice in my hand and I'm shaking them, versus when I'm rolling them, all that stuff. I want to sort of be able to look at it, look at the data, maybe transform the data somehow, and look at it again, but essentially compare it exactly and know, like, oh, here, this is the exact moment where it landed, match that up with the data, see if I see a spike, here it's rolling, here it's stopping, etc., and see if I can figure out smart rules for it, right? You can sort of think of it as I'm trying to train a neural network to detect states, except the neural network is the actual one in my head, and trying to come up with some rules for, how to write code that in the end I'm hoping is not too complicated, basically, to determine, like, oh, hey, I'm being just put back down on the table. I haven't actually rolled, for instance, or so I do this. I'm like, oh wait, no, I only need one die. So I don't want that die to just sort of report like, hey, I've been thrown, and I registered a 4. I want to be able to tell the differences as well as possible. Anyway, so all this to so all this to get some data, get a bunch of data, And then, you know, hopefully if I can actually put it on a phone, I can go like take my dice to, you know, buddies and like, you know, record them playing. So it's not just me and my throws and the way I throw the dice. So, but first step is to actually finish this firmware. So we're going to do this. This class here is essentially my LED abstraction, and it has sort of global define, okay, a master define that will either sort of enable the RGB LED circuitry and talk to those, or the version 1, excuse me, LEDs, which are called GPIO LEDs because I essentially just toggle them on and off with GPIOs, and then talk to those. So internally, like everything in all the other systems is still treating the LEDs as if they were full color LEDs, just to make things simpler. But then at this level, if you're only using the GPIO LEDs, it will just take like the intensity and use that instead of a full color. So I'm at the point where I have everything routed through here, except I haven't actually implemented any of these functions. And so this is what we are going to do here. LEDs. There we go. So of course, a lot of this stuff is probably not going to make a lot of sense without context. And I'm just going to have to apologize for that because I can't spend all my time sort of like walking you through all the details. But if you have at least somewhat specific questions or questions about programming, just feel free to ask. I'll be more than happy to answer. So right now I'm doing the C++ thing, which you do all the time, which is like when you declare a class in a header, then you have to go and implement all the methods. And I typically do this kind of stuff all the time, like having to recreate all the definitions. Woo! That's a thing that I really enjoy with like C#, for instance, that I don't have to do any of this nonsense. All right, so the constructor, I believe, in the case of RGB LEDs, I have these APA102, which are the actual ones that, well, this is the actual class that talks to the hardware. And I believe, right, there is no special constructor, so I don't have to do anything. The GPIO LEDs either, and the LED controller, that one I do. Hold on, oops, there. Oh, so the Piano Addict asks, for how long have you been programming? I don't know, somewhere between 15 and 20 years. Professionally, only like maybe 15. But yeah, and mostly in video games. So yeah, like AI, graphics, that kind of stuff. A lot of fun, actually, to be honest. Okay. All right. Defined. All right, so if not define RGB LEDs, then I want to construct my controller with the message queue. I believe that is correct. Where am I? There. Yes, controller with the message queue. Perfect. RGB LED. There we go. Okay. And it's happy, which is great. Right, so we're gonna have a lot of if-defs here, because that's essentially the purpose of this file, is to sort of, I say abstract out, right? But of course it's not like a C++ abstraction. It's literally a hard-coded abstraction. What are these called? RGB LEDs. Is that right? Yeah, RGB LEDs init. Otherwise, GPIO LEDs init. Oh, whoops. Wrong way. Init. And then controller. Yes, begin. Perfect. Now update. This is where I should process my message queue. So while oops. I actually still have a bunch of if-def. While message queue, try DQ. Message, I need this. Message queue. Wait, really? Oh, I need this. Using namespace core. Message queue, message, DQ the message, and I don't think there's anything to pass in. Yep. All right. Very good. The piano, I study embedded system programming and cybersecurity, but all that means is I know how to do some basic C++ on Linux systems and know how to use Kali Linux. Still learning. Well, hey, you know what? I don't know how to use Kali Linux. And hello, Sundeezy 98. So what am I programming? I am. So this is it's a long sort of dive down what exactly it is that I'm programming, but I'm working on this project to make a small electronic dice, right? So these are prototypes of it. There's like a painted one and a translucent one, and you can see they light up. Or you could maybe see them here. You see them here? Oh, actually, hold on. I can't see what I'm doing. Right. Same thing here. And I did all the electronics for it. They use like small microcontrollers inside and a bunch of LEDs. And they also talk Bluetooth. And the idea there is to make some cool use of, connectivity. So they can light up, do animations when you roll them, and it's all nice, but you can also do more stuff if you have like a phone connected or an iPad or whatever. I'm working on a second version of these, but I'm also writing the firmware for this, for them specifically. And in the firmware, right, which I am writing in C++, using a tool called Visual Studio here. This is what you're seeing on the screen. I'm trying specifically right now to write a class that abstracts the different versions of LEDs my dice have, because the second version of these dice will have RGB LEDs. And on the stream yesterday and the day before, I did some some work on that, and you could maybe go on YouTube. Yeah, if you search for me on YouTube, if you're interested, I mean, or in the Twitch archives, then you can probably see like me mess around with the RGB LEDs. But so right, from a code's perspective, they work completely differently, and so I want to try to make my life easier for in the short future, in the short term, by abstracting out the different ways I can control the LEDs. So this is what I'm doing right here. And in fact, I don't know how familiar you are with programming and C++, but essentially this is why I have all these if-def in my code in this specific file, because I have to like write the code differently if I'm working on version 1 of the dice or version 2. All right, so message queue, try DQ. Right, now we are going to have a bunch of cases here, which I think I forgot to, I didn't declare anywhere. I don't need to, I can do it here. All right, I'm gonna define some constants, and I will do the same thing again. If, whoops, defined RGB LED, then define what was it? Oh, message type. So I have a bunch of them that I need to declare. Set LED, clear LED. Wait, no, that's not right. Yes, is that right? Yes. Clear all. Okay. Define message type set LED. I'll call it 1. Message type set. Oh, I don't need those two. Message type set LEDs 2. Message. I don't need this one either. Message type clear all. Call it 3. So that's cool. Actually, these are always defined, but then I need more if we're not using the RGB one. I need more messages. Message type LED on. And I'll call it 4. Define message type LEDs off. 5. So these are internal. There we go. Oh, yeah, actually. GPIO message type. These actually I will want to let me think. No, I want to keep them here. Okay, cool. All right, controller, message queue, blah, 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 blah. All right, so here we go. So, don't want this. I want to handle the regular cases. Case message type LED1. Very good. Case, whoops. There. All right, that's great. While, oh, I need a switch statement, right? Type, there we go. That will work, whoops, that will work much better. Let's do this. All right, and now if we receive, if we have a message to set an LED in our queue, we will, this is, what do we do? Let me think about this. in the case of, all right, ugh, if this sucks, if define RGB LED, whoops, nope, not this one, RGB LED, else, and if, okay. So here, if that's the case, we want to use RGB LEDs and what? Yeah, RGB LEDs set message dot what is it? Oh, I can't see it because it's not defined right now, so it won't show it to me. What I want is int param and color param. Okay. Yep. MSG color param. Done. Otherwise, LED controller. No, controller, I believe is what it's called. Yep. I want to set an LED. The index is message.intParam. And I want an intensity, not a color. And I actually happen to have some code that will kind of roughly convert wait, hold on. Controller is local, right? Max get rid of message dot color param. This is what I want. All right, so in the case of it's msg dot int param. Okay. Right, so in the case of the GPIO LEDs, the single color LEDs, then I essentially grab the max value of all the components. I don't know if maybe I should use, you know, the average or something, but for now I'm just doing the max value. So the if define is also something you find in 3D printer firmware like Marlin, so that you can customize it for your 3D printer. Yeah, exactly. Yeah, you want the users of your library, like, or in the case, the person that's going to try and compile, right, the 3D printer firmware for their specific board. You want it to be as easy as possible, right? To just say define this, define that, you know. You don't want them to have to go edit like your code everywhere and go like, oh yeah, turn this off, turn this on. So yeah, so essentially that's what I'm trying to do, right? So that in the end, if I want to, compile for, the new version, I just uncomment this over here, and if I want to compile for the old version, I just, comment it. Ideally, I'd put it somewhere else, but whatever, that's a detail. Yeah, so anyway, right here, I'm essentially dealing with specifics of how the firmware works, and more precisely, difficulties with trying to control the LEDs from callback functions. Right, so the animation, for instance, controller is updated on a timer at specific intervals, and that happens inside an interrupt routine, right? So there's code that sets up interrupts that say, to the hardware, like, hey, I want this function to be called every so many milliseconds, and it will do this, and that's called a software interrupt, or timer interrupt in this case. The problem is there's certain things you can't do from within an interrupt, and a lot of those things, or the main thing that you can't do is use other interrupts or wait or rely on other interrupts while you're inside the processing code for an interrupt. Seems to make sense, but it's kind of more what's the word? less obvious that you are using interrupts when you're trying to talk to devices through the hardware. So for instance, when I try to talk to the LEDs, I'm using the I2C interface, and it's exposed to me really easily. I have functions to send data, receive data. It's great, but internally those things actually rely on interrupts for the timing, and so you can't actually use those functions reliably from within an interrupt. And so I have to jump through all these hoops to like post messages to myself that I can process in like the main loop of the program, so that they happen outside of interrupts, but roughly at the time that they're supposed to, and just complications of that really just have to do with like the specifics of the implementation. In any case, here, if we are setting multiple LEDs at once, I believe I have a thing that does that. Do I? RGB LEDs. So this message will be posted when it is requested that we update a bunch of LEDs at the same time, sort of as an optimization. And I want to see if my actually my LEDs don't have that, do they? No. Okay. So I'll just loop. I shall loop. All right. So we'll write a loop for int I equals 0, I less than message dot. Of course I can't see it. Message queue count. Yep, it's correct. Plus plus I. I can do RGB LED set message dot indices I message dot colors I. Is that correct? Indices, colors, yep. Perfect. False, because I don't want to flush it. Because if we can look at this function, oh, it's right here. It has an LED index, color, and whether we want to flush it, which just means actually send the data over. But I don't want to. I want to do it at the very end. And so I'll do that now. What is it called? Show. Internally, this just flushes. Yeah, it's just the same. If flush, show. So anyway, so all right, we do this. But in the case of the GPIO LEDs, do I have a thing? GPIO LED controller has a function, I believe, somewhere. Public set LEDs. See, wasn't that nice? One not nice. Set LEDs. Message dot indices. Message dot colors. And I want this to be message dot count. Great. But all of a sudden I am. Wait. We'll worry about this later. Excellent. Here, if defined RGB LED else, and if, all right, clear all. I want to RGB LEDs clear. I believe that's it. RGB LEDs. Oh wait, no, not here. Clear all. I think I want to controller, clear all. There we go. Will that actually clear them right away? No. That's fine. Yeah, I think that's fine. No, I think I want to... Do I want to update them right away? Oh, get rid of undefined. I got it. I got you. I got you. Include utils. There we go. Okay. I have to think about this, but that's fine. I don't care. All right, so LED stop. I don't think this does anything. Well, we'll still add the code. If defined RGB LED, else, and if. Okay. RGB let's dot stop. Do I have that? I think I do. Init show clear. No. Oh, okay. Well, what about LED controller? This guy here. There's a stop, so we'll call that. And the GPIO LEDs, nothing. Okay, that's fine. So we can just simplify this. If not defined, then controller stop. Perfect. Why are you not happy? See? Oh, it'll be fine. All right. Set LED now. Right. Oh, but I'm not finished with this switch statement. Now, right here, if I am in the version 1 mode, I want to handle more messages. So GPIO message type LED on. And case GPIO message type LED off. And this is yet another complication of how the work is, or how the other stuff is implemented. My version 1 LEDs, single color LEDs, are Charlieplexed, which is a term meaning that they share pins, essentially, right? Like it allows you to control multiple LEDs with a few number of actual inputs and outputs. But it means you can actually only turn an LED, one LED on at a time. And so to actually fake variation in intensities and multiple LEDs, you know, turned on at once, I actually, you know, turn them on and off like really quickly, right? And it uses the persistence of vision, right, to make it look like they are, you know, on. They're all on at the same time. And so, but internally, what's happening is that this little LED controller, right, is constantly telling the actual like LEDs, you know, turn on, turn off, turn on, turn off, right? And it does all the the management of how long an LED should be on and off to sort of emulate intensity. And that runs through the same issues, right, of needing to sort of delay the actual operation of talking to the LEDs, etc. So yet again, I have to use this, you know, messages, you know, to sort of like postpone the actual operation. And so in this case, the controller here that we've been, right, so the external code, the code external to this, right, when it says, hey, turn an LED on at, you know, I don't know, full bright, or let's say gray, then this code here tells the controller, the little LED controller, oh, okay, you know, turn this LED at, you know, 50% brightness. It then, the controller, in turn, is constantly pushing messages to this little queue to say, okay, turn this LED on, turn it off, turn it on, turn it off, turn it on, turn it off, turn it on, turn it off, to, you know, emulate 50% duty cycle. So this is what you're seeing me sort of re-hook up in this code. Set, no, not LEDs, GPIO LEDs. Oops. Set message dot index int param. There we go. And then in this case here, clear. Perfect. Okay, so that's good. Right, so if I scroll back up here to the constructor, for instance, with this guy, right, it internally, right, so it has this message queue internally, and the controller, and the LEDs, and it initializes the controller with the message queue, right? It tells the controller, here is a message queue, and the controller will then post that message queue, LED on, LED off, LED on, LED off, LED on, LED off, and then it will come through this, you know, update function, and it will turn, you know, the LED on, the LED off, the LED on, etc. Now, I have, on the other hand, declared all these set LED now, you know, set all now, clear all now, to actually do the work right away. Mostly purely for the initialization code that I was working on yesterday, where it lights up all the LEDs and, you know, then does like the 1 to 6, you know, as it initializes modules. Because, right, the you know, the stuff isn't running yet, right? There's no update going on and all that, right? So if I use the regular functions, we wouldn't see anything until everything's done. So I want to make sure I have these set LED now functions. And so we're going to do the same thing of like, hey, actually, I can just do this. Set LED now. Hey, message dot, oops, right? So dot int param, message dot color param. There we go. This is called refactoring, you guys. And I can just do, oh wait, that's the wrong kind. Whoops. This one wants to be here with an index and a color. Burp. There we go, right? This one's gonna be easy. We just call set LED now with, what is it, LED index? Yeah, there we go. Face LED color, right? So we just call this version down here. And it's great, so we'll do the other one as well. Boop. Set LEDs now. Whoops, now. Message dot indices, message dot colors, message dot count. Right? What is wrong here? What? Oh. Yes, of course. All right, UN32T colors. Perfect. Okay. Set LEDs now. Put it here. And again, we don't need this. There. Here we pass it through directly. Tink, tink. Oh wait, no, actually I don't want this. I want to do, I need to fix that array thing. So where is the function? Let's do 2 grayscale uint32t. Oh wait, color, and I will create that function with the other color stuff. I think I had them here. Yeah. Const per byte get grayscale. How did I spell it? Grayscale with an E. uint32t color return. Is that correct? Return max of all these. Yeah, sure. We're gonna say that's correct. All right, cool. Let's get grayscale. There. And for this one, I'll create, well, I'll have a local array, byte intensities, what is it, 21, and then for int I equals 0 to count intensities I equals get grayscale of colors I, right? So we're converting, and now I can pass in intensities, right? Does it not want, what does it want? It wants int. Okay, sure. Don't know why, because it really is just bytes. But whatever. Alright, I gotta take a quick bathroom break. I'll be right back. Alright. Thank you for waiting. Alright, so we have set LEDs now. Set all now. Set all now. We can do that. We can do that. Alright, so set all now. In the case of RGB LEDs, we just want to pass in, we want to create a small intensities, no, indices, and blah, blah, blah. Indices. Oh wait, what am I doing? Don't need to do this. I can just do set I to color, and then show. Perfect. And then for this one, I want intensities and indices. Indices. 0, 1, 2, 3, 4, 5. Oops. 6, 7, 8, 9, 10. 18, 19, 20. All right. Oh, yeah, I didn't need to do that. I can just do this. Well, technically, the first version was slightly better because it could be a const array. But, you know, it's going to be fine. All right, grayscale. Okay, intensities, and that's all of them. Wait, didn't I have a defined for LEDs count? I don't. That's weird. Let's, yeah, let's do that. There's no reason not to have one. There we go. LED count. 21, 21. Ah, much better. Clear all now. I believe we have what we need here. So we can do this. RGB LEDs. Do I have a clear? I thought I did. Clear, yep. And in the case of version 1 LEDs, we can do controller clear all and LEDs, no, RGB LEDs dot, wait, set all now. That's wrong. Actually, that's not what I wanted to do. Wait, what do I want to do? Clear all now. Wait, hold on, I'm trying to think about this. Yeah, actually, that's not what I want to do. Set all now is not actually a valid thing. Ha! Crap. Alright, because by I don't know, by definition, this the version 1 LEDs, there's only one LED that can be on at a time. This one's fine. Oh, hold on. Let me take this really quick. Okay. Right, so I was debating this set all now thing because it actually doesn't work. I guess what I can do is no, I'll just leave it as this. So it won't actually do anything, and yeah, all right, whatever. I'm just worrying about too much, I think. Set all now. Okay, all right, and then set LED with the color. All right, so these are the ones that are going to delay the actual work. There's a few things that I need to do here, which is if defined RGB LED return RGB LEDs dot where is it? Oh wait, it's not RGB, it's APA 102 LED index phase LED else else strange return GPIO LEDs that index face LED. Okay, so that's fine. Set LED, this will create a message. All right, so message queue, message MSG dot type equals message type set LED MSG dot int param equals LED index face LED MSG dot color param equals color. Awesome. And then message queue push enqueue rather message. There we go. So when external code calls this, say set LED to this color, essentially it's queuing it up, and then on update it will get the message and process it and actually do the work. Now the thing that I am worried about here is that these arrays are not they're not going to persist after this call, so I'm going to need to copy them somewhere. I'll copy them in here. I'll create alright, so I need int 21 queued indices and UN32 queued colors 21, and then I'll just use those instead. Yeah, that's kind of weird, but it's fine. I don't want to allocate memory. That's kind of dumb. Seems dumb. All right, so set LEDs. I want to copy the stuff, right? So I want to do memcopy. Is it an S? No, memcopy. Really? You're not going to show me? Destination, source, count times size of int. Memcopy destination colors count times size of uint32t. All right. And here I want to set indices to queued indices and color param to queued colors, and then count to count. What's wrong? Oh, yeah, no, I don't need this. Pointer is pointer to the array. Huh? Oh, it's not color param, it's colors. Much better. All right. Thank you, Visual Studio. Okay. So we queued all this. It's all good. We're all happy. Set all. Did I have a set all? Yes. No, I have a clear all. Yeah, let's create a message for set all. Oops. Okay, so then we'll do this. Message queue, set all. We don't have a color, but we have a color param equals color. and then we'll process it up here. Set all. All right, very good. Let's see, set all, blah, blah, blah. Set all now. Okay. All right. We have all our messages. I don't know why it thinks memcopy is undefined. It's okay. Compile. Oh no! It is not happy. Really? Oh, it doesn't like compile. Alright, that's fine. Let's build. Also, I want to get rid of these shim references. It's weird. Oh no. Wait, what? GPIO LEDs. LED index. Oh, it's devices. Not sure why I did that, to be honest. But whatever. Oh yeah, I did do that. Okay. All right, what's next? Stop all. And define reference to LEDs and controller. LEDs. External LED. Oh, forgot that. Just do this. All right. Cool. All right. So everything compiles. That's great. Okay, so now we need to figure out what works and what doesn't. Dun, dun, dun. Set LED, set LED, set LED. Let me think about this. I need. Oops, sorry. LED count. Update. Fine. All right, so the thing is the initialization, right? So if I go into die.cpp, my main initialization, which we saw yesterday, and I'm using the LEDs sort of as indicators. There's a problem that essentially this set all now isn't going to have any effect because we're not going to be updating the let me think. Alright, you know what? I won't worry about it because I don't want to worry about it. Alright, so let's use this little guy here. Oops, if I can show you. Oh, does this camera not work? This one? No. Well, anyway, I have this, right? So it's a dye version 1, attached to a USB plug, so I can try it out. And I'm gonna plug it in. So, all right, let's see. There, maybe I can zoom you in. Oh, something's on. There. Whoops, what did I do? Okay. So yeah, it's the current firmware on there. It just lights up all the LEDs, depending on which face and all that. Which is all cool. But now I want to reprogram it. Oh. Let's see. Uploader. Oh, 3. Okay, it's uploading. All right. So nothing's happening. This is not a good sign, is it? All right, so we don't need COM10. We want port monitor. Init, module init, sending face number 1. Yeah, we should be correct. But of course the LEDs are not happy. Nothing's happening. All right. Let's try to figure out why. All right, so we initialize our LEDs here. Let's go in there. LEDs.init. GPIO LEDs.init, and then controller begin, which is fine. Oh, wait. No, that's correct. Controller gets passed in the message queue. Yeah, that's fine. Begin, and then an update. There's a message. Oh, you know what? There's a thing we should probably do. It's wait, what? Oh, wait, no, the controller actually doesn't need to be, because inside begin it will register with the timer. Yep. LED controller update, and then right, its update gets called, it does all its blah blah blah. Oh, right, and that's the wrong code. So I really don't want this anymore. Kill it with fire. message queue either in here or here. But in here, I will do it manually. Message queue, message. MSG dot type equals. Let me think. Oh, actually, it's, oops, sorry, it needs to be one of these two, which I did not, right. So actually, I want to have those functions here. Yep. Do I want those here? Okay. That it will type GPIO message type LED on message dot int param equal next LED index message queue dot enqueue message. There we go. And here we clear. Wait, it's not what? Right. Excellent. Okay, so that's good. I wanted to do one thing, but I forgot what it was now. Yeah, this kind of sucks. Whatever. Okay, let's try that again. Oh, right. I need to include it. That's what I wanted to do. Oh, wait. Yep. Yes. All right. Now it's going to start programming. Why is it taking so long? Oh, did I build and not run? Uploading. There we go. I was like, what the hell's going on? Hey, something's happening. Oh, look at that. We have faces. Oh, wait, did I move it out of view? Whoops, look at that. 4. Here, 5, 6. So, for the most part, it's working. Cool. Let's see if we have telemetry data. All right, so that's good. Let's open Bluetooth and devices and yada yada yada. Let's add a Bluetooth device. See if we find it. Jon Snow is its name. Oh, there's also Brett over here. And Jean. Hey, bunch of dice. Oh, wait, actually, let me turn those off. There we go. Let's cancel and do that again. Make sure. Oh, so this was Jean, actually. See. All right. Connecting. We're connected. Oh, yeah, you can't see that. Oop, there we go. So that's good. All right, let's open Unity and see if we're receiving telemetry data. Central. There we go. All right, move it over here. Telemetry, I guess we'll just run it, see what it says. We have graphs. If I shake this puppy, oh yeah, look at that. Nice. This is very cool. Right, so like I said, I had done some work on this already so that the die sends a bunch of telemetry data. Right, so it internally is responsible for determining what phase it's on. And it will send messages that say like, hey, I've detected that I'm on phase this or that. But I also have this sort of like side channel of telemetry data, which right now I'm going to use to try and, figure out information about when the dice is being rolled versus thrown versus handled versus put back down, etc. But yeah, this is good. This is good. So I'm gonna have to do a little bit of Googling for the next phase, right? Which is, so here in Unity, I want to record a video and I want to record wave files, right? Create my own wave files and record them to disk, and then see if the two are timed correctly to match them up, so I can open them in a brains getting fried. Open them in a video editing software so I can see the video of the die being thrown with the telemetry data. So let's look. Let's open a Google page. All right. Let me switch you over to, let's see, this side. There we go. And we are going to do some Googling on stream. How fantastic is that? Unity, record, video, camera, video capture. Use the video capture API to record videos directly to the file system. Wow, that's pretty nice. Please note that the video capture API does not work in the Unity editor. Blech. Cool, we have an example video too. It's a VR thing. I guess that makes sense. So there, they added this when they did a bunch of VR editions. It would make sense. Let's see, how does this work? So you declare a video capture. Supported resolutions. Oh, we grabbed the supported resolutions, or the highest resolution. Oh, this is nice. This is a nice interface. Supported frame rates, and they're also getting the highest frame rate, which is great. And then create a sync. Whoa. Okay. And then you pass in a delegate that gets called with the video capture device that is created. If it worked. If it gets one, yeah, because I guess it takes some time, then it assigns it to a local parameter and set a bunch of stuff. Look at that, camera parameters. Hologram opacity, what the what? Frame rate, resolution. What are those camera parameters? Curious. Pixel format, that's fine. And then that function calls start video mode async with the parameters. Okay, right, so create the video capture, then we start it. Oh, we can specify mic audio, which is nice. And then we call on started video capture mode when it's done. Okay. On started video capture mode, started video capture. Then we generate a file name. Yep. Persistent data path. There we go. So that's where it puts it. Oh, interesting. It replaces it with backslashes? That's funny. This line here is weird. Like, is this specifically to work on desktop, like on Windows? It's weird, right? Anyway, doesn't matter, I guess. Where does this on stop video capture past? I didn't see it. On started video recording. On started video recording. On stopped video capture mode. Stop video capture mode. I'm missing this. Oh, wait, here. Ah, got it. Start video capture. Right, video. If it's longer than a time, then we stop recording. Great. On stop recording video. And then on stopped recording video. What is result? Where does it come from? Oh, it gets called with some results. And then stop video mode async. Oh, I see. So you use the same interface, video capture, to start acquiring video, but also to record it to disk. I believe I'm reading this correctly. Alright, so video capture, start video mode. Alright, once the video mode is started, you start capturing it. I mean, you start recording it. Right, yep, start recording it. Once it started recording, we set up the timer. Interesting, so we only set up the timer then to stop recording after a certain amount of time. And then to start recording, we do the same thing in reverse. We tell it to start recording. Once it gets back to us, it tells us, hey, I've stopped recording. It probably takes time because it's finalizing files and all that kind of stuff. Then we can stop acquiring and actually do stuff. All right, so let's try that, and let's see if I can use one of these cameras because I'm all using them for streaming. It's fine. All right, well, I'm going to start by copying this whole thing. Bloop. All right. Scripts, create. C# script. Let's go back over here. And I will call it video capture. Okay. Replace everything. Oh, do not call it video capture. Telemetry capture. How about that? It's way better. Oh, also, why? Hold on. Sure. Oh, thank you for doing that. That's nice. Let's see, what did you do? Unity Bluetooth LE, that's not what I want. I want telemetry capture. There we go. Oh, look at that, it cleaned everything up. Oh, Unity Engine XR, not VR. Since, yeah, this update stuff is kind of cool. It worked. Like, it automatically worked. Hey, hi, Semaphores. I'm still working on that. Yes. My condolences. No, I love C#. It's fun. It's easy to write stuff quickly in C#. So, yes, hi, welcome back. What I am working on is exactly that, actually. I've been sidetracked working on version 2 of the board with full RGB LEDs. I have some pictures, I think on my website somewhere. Also, you could check out some of like the stream archives. But I took a break from that to get back to the telemetry thing and figuring out the algorithm. So my current plan of attack is to actually make a little app that will record like a play field, right? And store telemetry data at the same time, and actually put the telemetry data in WAV files so that I can open the entire thing, like the recording and the telemetry for all the dice in a a video editing software, and sort of like see, right, the data matching with what's actually happening to the die. Because the problem is, right, like I'm just recording a bunch of stuff and I have no idea what it matches with. And I think this way I'll be able to hopefully, you know, extract out some interesting, you know, pieces of information from it. I'm hopeful. I don't know. Worst case, I'll, you know, learn how to create a neural network and give it a bunch of data and and try to train it, or so. I don't know. Probably not. But yeah, I'm hopeful to like that by being able to like know exactly what my data matches with. I'll be able to, you know, get good insight and come up with, you know, fairly simple rules. I mean, clearly, I already know that if the readings don't change, you know, at all, or like less than 1% or 2%, or, you know, the dice are probably static, right? Like they're not moving. And also if they're pretty much exactly at, you know, what do you call it? Like cardinal orientations, then they're probably, you know, on a table and they're, you know, etc., as opposed to just, you know, sitting in my hand, like a bunch of stuff. Hi, Short Circuit. It's going well. Thanks for stopping by. Around what you just said, yeah. No, I mean a wave file, right? It's a one-dimensional piece of data. It just typically it's you know, it's sound frequencies, and I think my data is going to be way too slow, right, to hear it. But you know, like all the tools will graph it for me, right? And so I can see my waveform, and I can see like, oh, look, there's a spike here. And then, you know, if I in my tool I have the video, I can scrub, and I can see, oh, the spike matches, you know, 0.4 millisecond before it hits or after or whatever, right? Like stuff like that. Yeah, I don't know how I came up with that. I think I was watching some other video. Somebody had essentially done something like that, just putting data in a WAV file because it was easier to deal with that way. I can't remember. Yeah, anyway. Oh yeah, I think it's people like trying to measure RPMs through sound. So they'll record something and then look at it, you know, like do a spectral, whatever, a Fourier transform on a tool, and then look at the spikes and see like, oh, yep, this is, you know, this is the 60 hertz and this is, you know, the actual RPMs and stuff. Anyway, it's a thing, I guess. People have done it. it's a format that a lot of tools know how to open. So it'll be interesting. Anyhows, so yeah, like I said, there's some maybe some archives somewhere and a few pictures of like RGB stuff. But I have a new board coming, maybe tomorrow or the next day, and I'll be putting that together with essentially it'll be like the final version of the layout for the next revision of the dice. And so I'll put it together and make sure that everything works. The wireless charging, the RGB LEDs, which, I mean, I know they already work, but I made a few last minute changes. Wireless charging, RGB LEDs, magnetic switch, and of course accelerometer. And if all that works, then I'm gonna send off, you know, the getting flexible PCBs made. And then in 3 weeks or so after that, so maybe 4 weeks from now, if I'm optimistic, I'll have version 2 of the dice ready to work. Fourier magic, yeah. Yeah, no, that's what people do, like Fourier stuff. It's cool. It's like super clever. Like you hear, right? Like you hear the RPMs on any motor, right? Like the sound it makes is essentially a function of its actual rotation speed. And so if you actually look at it in the spectrum, you can sort of, yeah, see it. It's kind of cool. Anyhow, so right now I'm back in C# and Unity just because that's the thing that I, you know, that I like, that I'm familiar with. And I was showing this right just before, which maybe actually you have already seen, right? Because before I got sidetracked working on version 2, right, I was working on this, getting better telemetry data for this dice, and so this is what we're seeing here. You know, it's sending data at 48 frames of data a second. Woohoo! That's essentially the maximum speed I can reach for this telemetry data. Right, and so what I'm trying to do now is use this sample. Where is it? Over here. This sample video capture API from Unity, because they have all kinds of stuff. And I want to see if it works, if I can record videos and record them to file. And then if it works, I'll adapt it for my own needs, and I'll start trying to create WAV files myself, which is kind of the same thing, or a similar thing. All right. Starto. Telemetry capture. So let's put a new component here. Telemetry. Oh, you know what? I already had a telemetry object. I can just add a new component here, right? Yes. Telemetry capture. There we go. So this example is grabbing the, let's see, video capture, start video capture test, video capture, supported resolution. All right, so it's grabbing the highest resolution, the highest frame rate, and it starts a video capture device. How do I know which camera I'm capturing from? Oh, I see, this is Windows. I don't want Windows. I mean, I do for now, but I actually don't want. I want to be able to do this on iOS too. So that's there's an iOS asset. I don't want that here. Sorry, I'm looking at assets. Webcam texture? What the hell? There's a bunch of webcam texture. Interesting. So that works, huh? Huh. But I want to save it. Unity. Save webcam texture. Webcam stream to image. let's see, record. Blah blah blah. There's other forms. Texture, raw video stream in Unity. Oh, that sucks. Record webcam to file. Let's try the asset store. Doop, doop, doop. What's going on? Hello. Create your first game. Oh my god. Oh my god. That's funny. All right, so I know webcam, netcam core. No, let's just search webcam and I want free. Face tracker, marker, timeline. No. Webcam. Netcam Pro. $75. Jesus. Camera. No, that's not what I want. All right. All right. iOS camera record asset. Yeah, but this was platform specific. Yeah, this is the Windows stuff. Again. Unity answer. Capture video from camera and iOS. Oh, that's the one. When your developers use camera on your iOS device, capture video. Also allows you to load a video from the library. Blah blah blah. Plugin allows to load following. Save videos to device library. Cool. $10. Is it any good? Blah blah blah. Screenshot plugin. Nope. Capture and save. Save and pick. Video capture? What does this do? Enables Unity. Put a capture video, audio from Unity application. Nope, that's not what I want. Wow. Okay, right over. Do 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 do. All right, well, let's try this on Windows first. And see, yeah, let's see what happens. So, okay, oops, why am I here? Okay, let's build. settings. I want, where are you losing my, add this, build, yep. Oh, error building, what? Do I need a, what do I need? How does this work? Hold on. Video capture. Oh, come on. Video capture. Oh, right. Wrong window. Again. Video capture. Blah, blah, blah. How does this work? Unity Engine XR. WSA. This is strange because I don't know why it won't build. I mean, it's telling me that it doesn't know about Unity Engine XR WSA. It does in editor mode, but it doesn't in the build mode for the build platform. Player settings. Let's see. Resolution, presentation, splash image. No, don't care. Oh, XR settings. Look at that. Oh, I see. Ugh, no, I don't want to build a virtual reality app. Okay, so that's gonna go nowhere. Okay, next. That's disappointing, honestly. I'm looking for, wait, no, wrong file. Oh, there we go. Alright, so this garbage I don't need. Let's try that asset, I suppose. I don't know. I mean, I wish there was a proper solution to this. Let's see. Unity, iOS, camera, recording. Oh, here. Looking at do it only for iOS. Okay. No, all right. say? Under core iOS features. Oh. Yeah, where is that? Live texture. Media player. No. Boo. Okay, forget it. All right, we'll get back to this. Yeah. All right. So, we will switch gear momentarily. And I think what I'm going to look into is Unity create a wave file. There we go. Save wave? I don't want to use that. Well, I guess I could, but I don't want to use that. Oh, it is. That's the thing. Save wave. There we go. That is one long file. Oh my. Right header. Oh, it's not that long. Do clip trim silence. No. Save. Let's see. What does this do? Convert and write. Create empty, convert and write. Samples. I like the look of this. Clip, get data, samples. Then we do a bunch of rescaling. Blah blah blah. That's fine. A bunch of like data conversion, and then we just write it. That's nice. And then we write a header with a bunch of standard stuff, right? It says riff. So funny. There's no magic to it. It's like, yep, creating a file. The first 4 characters as first 4 bytes as riff, because that's what the wave format wants, and then size of the file minus some buffer or something, and then some type information, some audio format thing, channel, sample rate. Yeah, it's great. That's fantastic. Yeah, I'll probably work with that. Oh yeah, clip sample times clips channel. Huh, I see. There's a bunch of like corrections. The hell is Phil-Gal threading? I don't know. Records. Cool. All right. Well, first I'm gonna take a break. I think. You know what? It's been a while, so I think I'm gonna maybe stop the stream and then start it again. Maybe a half hour or yeah, half hour, an hour or so. Because I need to take a break. But yeah, I think that's the goal. Well, we here we checked off 2 of the things that I had on my list. So I guess it's not all that bad. And I think I could get that plugin to work on iOS. I wish I could have a solution that works on Windows and iOS. But yeah, that's not the end of the world. I think I eventually do want it on a phone, so I can just take it somewhere and record, like my friends playing. But it'll be fine, I think. Yeah. So when I come back, yeah, like I said, probably half hour to an hour from now, I think. I'll do the WAV file stuff, see if I can get my data in there, and that's going to be interesting. And then we'll go from there. All right. Thank you, everyone, for watching. And hopefully we'll have more exciting stuff soon. All right. Bye, all.